Bismillahirrahmanirrahim. This video is about series clippers from Mr. Boylestad books on EDC, and here we'll be solving end chapter question 32. So straight away on the question, determine V out for each of the network for the input shown. So these are the two networks. This is the input given, and we have to find V output in both the cases. So we'll take one at a time. This is the first circuit. And our aim in solving these questions is to determine when will the circuit will become forward bias. Let's see first of all the positive half. The positive half, this will be positive, here negative. Positive of the battery is touching negative of the diode. That means the circuit is reverse bias. And so we'll leave it as it is here. Let's move to the next half. Negative 20, so negative here and positive here. Now negative of the diode is touching, negative of the battery is touching the negative of the diode. So this will become forward bias. And now since this is a silicon diode, we'll replace the silicon diode by a 0.7 volt battery. So replacing this by 0.7 volt battery, this is our circuit. And now we'll use the KVL equation to find V naught. So by KVL, we're starting from a corner here, positive 20 minus 0.7, positive V0. This is the equation. And from here, we can find V0 to be minus 19.3. Now remember, this is the peak voltage during the negative half. Now, how do we plot this? This was our input, negative 20. And our requirement is that the output should be negative 19.3. Now it's the same circuit, same distance, but we have to make it 19.3. That means we start counting, either we count from the top or we count from the bottom. Now if we count from the top, the gap will be more. We want a lesser gap, therefore we have to count from the bottom or the lower part. So our reference line will move to some point at the bottom. And how much down will this be? Actually, this will be 0.7 down. So 0.7 here and 19.3 will make this gap 20. So we'll write that our zero axis has moved to negative 0.7. Okay. Now how to draw the final wave shape? Actually, you can see from here, this is our 0 point. So we are going up by 0.7 up to this point, and then we come down. So a neat drawing may look like this. From zero axis, we are going 0.7 up, and then we come down to minus 19 point. So this is your final answer. And the solution manual also has a similar answer, except that he has not written here 0.7. It should have been written here. This is the first part. On the second part, there is a battery connected. This is called biased series clipper. And we'll follow the same technique. For the positive half, you can see positive here, negative here, positive, making this diode as reverse bias. Positive of the battery touching negative of the diode. So we'll leave it as there. We move to the next half cycle. So the negative half cycle will have negative sign here, positive here, negative of the battery touching negative of the diode. That means the diode is forward bias. And now since this is an ideal diode, we'll replace ideal diode by a simple straight line. So our next diagram will be like this, replacing the diode with a straight line, and this circuit now will solve by KVL. So by KVL from here, positive 20, positive 8 plus V naught, and therefore V naught will be negative 28 volt. Okay, how do we plot it? This was our input up to negative 20, but our requirement is that our negative peak should be at minus 28. That means we have to draw the reference line or move the reference line somewhere here up. So the reference line will move up, and this is actually we have to move by 8 volts. So 8 and 20 will make this gap 28. Okay, so move 0 axis to +8, and now we'll just draw up to this, and this. We'll follow the same pattern. So our answer or the final drawing will look like this. And a similar drawing has been drawn by the solution manual, except that in their case, this battery he has taken to be 5 volts. So this is becoming -25 instead of -28, and this point is -5 instead of -6. I hope you have been able to follow this. Let me know through your comments. Share it with your friends. Thank you.